For the first time at the National Space Symposium, we are hosting concurrent panels covering diverse topics. The Space Foundation is doing this to accommodate our customer requests to expand content during our symposium. The technologies used to power the International Space Station, the Space Shuttle, and other spacecraft operating as microgrids can be transitioned to terrestrial applications. The big question is how. Our distinguished panel this afternoon is well suited to help us answer that question. The panel moderator is Dr. Ron Sega, who is a former astronaut who flew on the first US-Russian space shuttle flight aboard Discovery and returned to space aboard Atlantis. He is now the Vice President and Enterprise Executive for Energy at the Colorado State University and the Ohio State University. Dr. Sega, we welcome you and your panel. Thank you.
Thank you very much. And if we have the first slide here. So the topic here is energy and engineering from space, powering the grids and markets of the future. And we'll focus on the role of aerospace. And as the long title that currently has enterprise executive in it, and I think that's a good way of viewing the area of energy as a system, as an enterprise. And I believe it takes a more diverse set of skills and disciplines as we move forward than it perhaps has in the past. And there's not only an opportunity, but I think a real advantage of bringing some of the skills from aerospace and the world of cyber into that mix. So I'll talk a little bit and briefly about energy and the environment and advances for aerospace. The needs for bringing methods and sources, efficiencies, and solutions for lowering emissions into aerospace products. But we're also going to concentrate on the skills and advances in aerospace for energy and the environment. In that case, a couple examples are the systems engineering expertise that has been built up for 50 years in the aerospace community, applying it to energy systems. This is a similar approach to looking at security of large and complex systems in aerospace being applied to energy systems. And then some future opportunities and challenges will be addressed by this panel. So for me, I was Director of Defense Research and Engineering for 4 years, 2001, 2005. We had three main areas, one in aerospace, one in surveillance and knowledge, and the other one in energy and power technologies that we paid particular attention. There's clearly linkages between those. And in the area of energy and power technologies, actually increased that percentage-wise more than any other area in the Department of Defense during those 4 years. Also, the issue of workforce was very, very important. So as we looked at defense systems and we looked at energy and power, we truly had to view them as systems. So not only did you worry about and look at options for power generation, whether it be on this slide, fuel cells and reforming of fuel and novel power sources, but also issues of energy storage and power control and distribution, switching, conditioning, transmission, distribution, thermal management, and so forth. So unless one had the whole system designed, it wasn't going to work. So for this community, we focused on space systems. Space-based radar is one example in this chart where having additional power available on orbit would be very, very useful. We applied the same approach to land and sea and air systems. So in the 2 years as Undersecretary of the Air Force, we looked at space systems. And so the systems approach, systems engineering approach to our defense space systems, looked at research and development, but also for the first time looked at energy as a strategy across the Air Force and in the role as the energy executive. So we had an energy strategy, but drew from the expertise we had in the Air Force in the area of systems engineering on the air and space side. So as we look at a space system, you can't have loss of continuity of service. And this example is GPS. The expectation is the availability is 1.0 of GPS for those on the ground. And if we add to that, in terms of capability, GPS 3A, L1C, and a bit more power, we don't want to lose a beat with respect to service. Same situation is present on our energy systems here on Earth. So another model of perhaps applying the approaches we've done in aerospace to that of energy. So we looked at making energy a consideration in all we did in terms of sources of energy, demand for energy, and a culture. So again, a systems approach. And where it made sense on the ground in the Air Force, the various places, we tried to take advantage of what was available to us. So in Cheyenne, Wyoming, just up the road, wind blows a lot. So the idea of putting some wind turbines on the base made a great deal of sense. Down in Las Vegas, Nevada, at Nellis Air Force Base, we had 14 megawatts of solar installed there at one point. Snapshot in time, it was the largest in North America. That made a lot of sense. Vehicles that were going to spend their time on military bases doing 25 and 30 miles an hour didn't have to go 120 miles an hour. Therefore, I looked to low-speed vehicles. So it was a systems approach to how we were looking at the problem. Now, as we look at aerospace advantages for energy environment applications, a couple examples would be space systems, and then a special example of the secure smart grid. And then looking at what opportunities the aerospace community may have in the energy marketplace. So this is probably the key chart for me. As we look at a secure smart grid, it has clearly elements of energy and the expertise and the discipline in the energy sector, utilities experience, power engineering, and so forth. But along with that adds additional elements of cyber and the security associated with cyber, and viewing it as a system. Kind of been a domain in terms of the discipline growing in the aerospace sector. So an intersection of energy, cyber, and aerospace, I think, are necessary for real advances in a secure smart grid situation. Now, if you looked at space systems, this case from an energy standpoint, I think this is, in fact, Atlantis, and Kevin Chilton is back there. He's on the left side up in front. I'm in the vehicle as well. But in this case, we're separating from the grid. Umbilicals are off. We're clearly disconnecting from power supplies, and at least I didn't notice, and maybe Chile you did, as we got the space, there weren't any wires hanging down to power plants. And so we were an energy island, if you will, using consumables of liquid hydrogen, liquid oxygen to support ourselves in space. And if we did need additional power, we had power down kind of checklists so that we would make sure that key elements that were important to our mission were kept alive, and the prioritization of other elements would be then made so that we did do some power down kinds of load shedding, if you will, that we would do it in a thoughtful way. Next stop on that flight was to go to the Russian Mir Station. Here you can view it as a zero energy district using renewable energies, and the systems that are necessary for storage, control systems on the vehicle, communications inside, as well as secure communications back to the ground to satellites, is something we have done in the space community for decades. Okay, many communities now will view it as something new. Up in Fort Collins, there's Fort Zed, zero energy district, but it is trying to be done at a more economical way, at a larger scale. But in any case, the principles have been done in space. This could be viewed as a docking or plug-in hybrid space version, where the shuttle and the International Space Station, and Mir Space Station in this case, are in fact connected with a little different sources of power. But in any case, we have done these kinds of things in the space community. So as we look at the International Space Station, and Paul Bollinger will talk a little bit more about that as we go forward, a little city in space, by and large, on renewables, storage, control systems. So as we have applied this discipline to launch systems and spacecraft, the suggestion is we apply that systems engineering onto the energy environment space. It's a complex system. Maybe there's other applications down the road, but for this session, it's for energy systems. So at Colorado State University, we looked at that. We have a Master's of Engineering, which was started in 2008, and then an MS and PhD that are doing research programs in energy systems, trying to develop the tools that have been present in the space community for a long time for space systems, but to look at the toolkit that could be expanded for energy systems. So also in 2008, we had the rollout of the Institute for 21st Century Energy, part of the Chamber of Commerce. The CEO at that time was General Jim Jones, to look at a comprehensive view of an energy strategy and a suggestion going forward for the country. Security was clearly a big part of that. In 2009, this region kind of came together to look at, could we get data in a test bed on a regional scale with some military installations involved, universities, national labs, industry, communities, utilities involved, so it would inform standards, best practices, security models, business models, policy and regulatory requirements, R&D requirements going forward, but get real data at sufficient scale, because we're dealing with a complex system, and some of these interfaces are very, very important, and I think you need data. Then, in 2010, a memorandum of understanding between DOE and DOD, and General Reneward had a great deal to do with this, looked at a strategic partnership to enhance energy security, signed by the deputies, the Department of Energy and the Department of Defense. Areas were many: energy efficiency, renewable energy, and so forth. Grid security, smart grid, and storage were clearly part of that MOU, with the idea of joint initiatives to include such things as a pilot or demonstration facilities. DOD installations may serve as test beds for such technical demonstrations. And we'll hear some words on Spiders, which is one of the sites is Fort Carson, right near where we are today. And Hilde Sanborn, who's the technical manager of Spiders, will talk to us about that as well. So in summary, we're looking at a systems approach to energy security. So there's a high level of complexity in energy systems. One could argue it's the most complex systems that human beings have ever built, the U.S. energy system. It's large, it's complex. It has been developed in somewhat of an ad hoc way from the 1930s to the present. Test beds, integrated tests at sufficient scale are important. That data then is required to validate models and form standards as we go forward. Partnerships are important. Government, industry, universities. It's a multidisciplinary effort. Multiple organizations are going to be important. A workforce that can accommodate some of these new areas is important. Universities clearly have a key role. And in our questions and answers, hopefully we will arrive at some additional opportunities and challenges for our space community as related to opportunities in the energy sector. With that in mind, our order here is General Reneward, and his background is former commander of NORTHCOM, setting kind of national need, and an example of how this could evolve was a joint concept technology demonstration, Spiders, which he was a supporter of, now run by Hilde Sanborn. Maybe some lessons learned from these kind of demonstrations for the utilities, represented by David Dykes and work in the utility area, and then finally with back to aerospace with Boeing and Paul Bollinger. Let me briefly introduce the members of this panel, and then they in turn will give some remarks followed by questions and answers. General Gene Reneward is president of the Reneward Group, LLC, and is the former commander of the North American Aerospace Defense Command and U.S. Northern Command here at Peterson Air Force Base. Previously, he was a senior military assistant to the Secretary of Defense in Washington, and he served as the principal immediate office advisor to the Secretary in all matters pertaining to the department. He had varied experiences throughout DOD. One was the J3 as on 9/11. Many of us were in the Pentagon, and he was our principal interaction to the users, the operators, for technical solutions. Next, Mr. Hilde Sanborn. He is the technical manager of Smart Power Infrastructure Demonstration for Energy Reliability and Security, Spiders, a joint concept technology demonstration in JCTD. So that's one of the key roles we'll hear about today. He's also the energy program manager at Construction Engineering and Research Laboratory, CERL, in Champaign, Illinois. He leads initiatives in joint service installation energy strategies and develops innovative energy supply, distribution, and demand technologies. Next, Mr. David Dykes, who is currently the federal segment manager for Georgia Power, a subsidiary of the Southern Company. He has been in this position for 19 years and has over 35 years with Georgia Power, working with its largest industrial customers. David also manages the General Services Administration's area-wide utilities contract for Georgia Power. And finally, Paul Bollinger, who's the Director of Government Solutions for Boeing Energy, and is responsible for the development of energy programs and services for federal, state, and municipal government agencies and other public entities. Paul was the U.S. Army Deputy Assistant Secretary for Energy and Partnerships, where he was the Senior Energy Executive responsible for the execution of the Army's Energy Security Implementation Strategy. He was also the Special Assistant to the U.S. Air Force Assistant Secretary for Installations, Environment, and Logistics. In that capacity, we had I think the good fortune of working together on the Air Force Energy Strategy, and the group ended up winning the Presidential Award for Leadership in Energy Management for the U.S. government. So you probably did something right there. So General Gene Renuart, you're up.
Great, thanks. Excuse me, and I apologize up front. You're never supposed to do that, but my voice is just coming back. And my friend, the plastic surgeon and dermatologist, has been working on me, so that's not my normal good looks. You know, it sounds cliche to say that September 11th changed everything for our country. I was serving as the J3, the Director of Operations for General Tom Franks down at CENTCOM, enjoying a brand new sailboat and relaxing in the life of Tampa Bay when those events occurred. And while we all know the history of what has happened militarily and the operations in Afghanistan and Iraq since then, that event also had a profound effect on the way we viewed energy, communications, transportation as a nation as well. For those of you that may have owned some stock in some of our national airlines, you know that the commercial air travel industry was hit heavily by the events of September 11th, and it's taken truly all of the time since then to slowly rebuild them back. But one of the things that really had a significant effect on the recovery efforts was the interruption to energy, primarily electricity, that occurred within the New York City area. I spent some time with Mayor Giuliani after those events, and one of the real challenges that they had for first responders was to reroute electricity such that they could close the perimeter down around ground zero and maintain energy in the buildings surrounding and allow first responders to set up sites very close in with full power. Obviously, they were able to use generators as interim, but as we all know, the cost of operating, especially an oil-powered generator, becomes fairly substantial. In addition, the power, the energy, the electricity required to run the command and control network had a significant effect. So that was really, it was a secondary effect of that attack on the World Trade Center, but a very substantial one. I would argue an equally profound event occurred on August 14th, 2003. Anybody know what that day was? Nobody. That's interesting. So 8 states plus Ontario, the province of Ontario, had their power interrupted. It occurred because of a fairly substantial voltage surge caused by essentially trees falling on high-intensity power lines in Ohio, but because of the way they were all connected, the states of Ohio and New York and Pennsylvania and New Jersey and certainly Michigan and Ontario were all affected event, causing the loss of power for, 55 or so million people. Out of that came a realization that our national, by the way, I was still the J3 at CENTCOM when that occurred, and the immediate assumption was it was a terrorist attack. They found another way to get to us. And of course, you'll recall during that period of time, everything bad that occurred was immediately assumed to be yet another attack by a terrorist entity on our country. And so even though that wasn't anywhere in CENTCOM's area of responsibility, Secretary Rumsfeld called Tom Franks that day to say, what are you doing about additional terrorist attacks in the homeland? And of course, at that time, Ed Eberhart, who was the brand new commander of NORAD and U.S. Northern Command, we referred that call kindly out to Ed so that he could begin to answer that. And he did what was expected. Don't know, Mr. Secretary. That's not part of our role. You might also recall in this same time frame that the Department of Homeland Security was being established. 22 different agencies coming together to provide an area of or focus on homeland security for the nation. Challenge was they were not fully manned. In fact, in the area of energy security, we're manned at about 0. And so we identified an interagency problem that was significant. Not only was there a vulnerability in our energy grid system, but there was also a vulnerability in our interagency ability to communicate on issues like this across government. And so there was some significant hand-wringing, I guess, if you will, on the part of the Department of Homeland Security, because they really didn't have an answer. And of course, they did what many agencies can often do, and they said, it's those Department of Energy guys, and they need to solve the problem. So what became clear to me just in my observation in August 2003 was that we didn't quite have a solution yet for the nation. But this, in fact, was a significant national security issue. Because if you think about the cities of Cleveland, Akron, Toledo, New York City, Baltimore, Buffalo, Ottawa, those are fairly significant cities with respect to economics and trade of our nation, of manufacturing for our nation, and certainly of government for the Canadian nation. And so a power outage has significant effect. The good news was it was relatively short-lived. It was back fully repaired within about 2 weeks, but certainly those main population centers were beginning to come back at about 11 hours. But if you're a patient in a hospital at 11 hours, that generator powering that hospital is getting danger close to fuel concerns. And so that whole infrastructure process that can sustain the nation on backup electricity was really being put to test. Secondly, fast forward to the summer of 2005, you have Hurricane Katrina. My predecessor, Tim Keating, at the time was the commander of U.S. Northern Command and NORAD. And you had a circumstance where Mother Nature interrupted power for a substantial portion of the Southeast, and to include virtually all of Louisiana, and the need to move very quickly with large numbers of both National Guard and federal forces into a region in order to ensure that you could reconstitute those areas. Many of those of those critical infrastructure facilities, power, transportation, hospitals, were completely taken off the grid with no means of backup. A couple cases in Louisiana hospitals had not tested their generators in over 2 years, and guess what? They didn't work. And so if you're a person on a ventilator, you're kind of relying on that hospital to have backup. Admiral Keating was asked the question, so what is DOD doing about that? Sounds like the same question that got asked of General Eberhart just a couple years prior. And the answer was still the same. Mr. Secretary, that's the role of the Department of Homeland Security and Department of Energy and all those other folks, and states, by the way, and municipalities. But in a crisis like that, nobody cares about who should have been paying attention. DOD becomes the principal face for most of those responses and is asked to come up with solutions to ensure that that doesn't happen again. Well, in this interim after Katrina, there was a study done. In fact, General Chuck Wald, who's across the hall, and Admiral Dick Truly sat on a board that looked at the effects of critical utilities on national security. Water, power, the transmission lines, all of the transportation lines that we have. How will they affect the security of our nation? And some in the military were surprised when they came out and said at the end of that, yes, absolutely, energy, specifically electricity, is critical to our national security. We are too centralized. We rely on too few points of failure in order to ensure the grid stays up. We don't have good connectivity among all of the 2,400-ish, some number of regional utilities, local community utilities, et cetera, and we've got to fix this. Well, about this time, the Department of Homeland Security actually is beginning to build some momentum, and they were given the lead role for what was called at that time critical infrastructure security or protection. The challenge is when we define critical infrastructure, most of the things that fit into that were things that we were used to seeing within the Department of Defense. Certainly our nuclear power plants, while they weren't ours, the National Guard had roles for securing them, as did the individual contractors, but there was really no national process for securing them. The rest were primarily our nuclear-related and our space-related command and control facilities, which fit under DoD. But interestingly, about that same time, DoD said, you know, it's really expensive for us to generate our own power. So we're going to buy our own power. We're going to buy it from all these different utilities around our bases, because if they can offer us much better rates than we can produce it for, we can reduce our infrastructure. We don't have to have, you know, power production people located on our bases. And so we did that. An example, Vandenberg Air Force Base, who has an aquifer under the base, sold the rights to that water to the state of California so they could buy the water back. If you're a golfer, you know that the golf course in Vandenberg needs a little more water. So some of those relationships proved to be challenging. Others have proven to be pretty good. If you're in Colorado today, we buy, Peterson does, Schriever does, the Academy does, we buy our power, our electricity from Colorado Springs Utilities at a pretty good price that they have, you know, I'm not an expert to say if it's been subsidized, but certainly they will keep that price for a while. So all of these issues began to show a dependence on that commercially available power. When I took over as Commander NORAD Northcom, I began asking the questions of our staff, because I didn't know the answers. How do we participate in this critical infrastructure protection? And the reality was we were not a player. And so we began an initiative partnering at that time. Dr. Sega was integral in this as well, but partnering with our military installations on what we call the Front Range to see if there was a way we could create a beta test to knit those various islands together to give them an ability to sustain energy in times of stress, to ensure that our critical nodes of power were maintained, and to look for new technologies that will allow us to secure it even more. And so that's really what the genesis of the SPIDERS program was. And I'm glad to see, pleased to have Harold here, but really glad to see that SPIDERS has taken on really a much more active role, partnered with PACOM now, and beginning to prove some of the concepts that we thought made sense for us some years ago. So with that as a lead-in, I want to turn it over to Harold and have him talk a little bit about that program.
All right, thank you, sir.
While Harold gets up there, the text number apparently is different in this number than you saw earlier today, so be aware of that.
Okay. Hi, I'm Harold Sanborn. I'm with the U.S. Army Corps of Engineers, and I'm happy to be here. I just saw the chart pop up. What did I do wrong here? Okay. Before I forget a couple of key points that the General was able to share with us, you know, I think in that 2003 zone, all we would have had to have is some controls that took the dominoes out of the line, and other areas wouldn't have gone dark. It was like a cascading ripple effect of dominoes falling and switches going off and breakers failing and those kinds of things. And so, you know, I lived through it, and, you know, 3 days is a long time in the summer when you want cool. And hopefully, as it relates to our infrastructure and our bases, another story comes up out of PACOM that they had a power outage for about 2.5 hours. The diesels failed to synchronize, and at the expense of human comfort, they decided to keep the computers cool, which I think is the right choice. You know, the people can go, you know, take their jacket off or roll up their sleeves. The computers don't have that luxury. So I'm not going to spend much time talking to each chart, and I think they're available afterwards. And so, you know, they serve as a prop really for me to talk about what I really am passionate about, and that's the partnership that we've established primarily through USACE's ongoing energy initiatives, but an outflow of what was mentioned earlier about the DoD and DOE partnership. And there's a lot of players in this, and people disagree on particular definitions and demonstrations. And a lot of times it varies to where you sit or where your perspective is of the problem set. And so this is just one definition, and I'm not trying to be that defining. I'll let DOE be the definition on some of these things. But the bottom line there is mission assurance based on aerospace systems engineering, which echoes what Dr. Sega just said. I mean, that is key. Treating energy in the bubble that we have, wherever you draw that line around the bubble, whether it's an installation, a building, several critical facilities, that bubble is where you need to apply a systems engineering process to figure out what your challenges and opportunities are. And so no matter where you do that, and mission assurance, I would also say, isn't just the computers in PACOM's headquarters. If it goes on for a while, you'd have to do laundry, and you'd have to have refueling and other kinds of things like that. So, you know, you have to think about the second and third order effects as you're doing power management. This chart here sort of addresses the Army's view, sort of from you know, just the Army. And of course, some of the technologies that go into that, some of the assumptions that go into that. But at the installation level, it's a fairly complex apparatus, and it, as I like to tell all the public audiences I see, you know, it's applying a new jet engine to the airplane while you're flying the airplane. You know, you can't shut the thing down to put a new appliance on the post. It just doesn't happen. So it's a challenge. Another way to visualize some of the things that you have to talk about as you begin to deconstruct what the problem set is and how you would address improvements. These things are, the technologies themselves are not the challenge. There's some integration issues, some handoffs. Hey, somebody comes in, they have the greatest wind turbine since, you know, whenever, and what they end up finding out is they have to plug into the balance of plant that the utility sits on. And so there's been stories in the press, and I'm sure some of you are aware of them, where, you know, the benefits that people anticipated didn't materialize because the systems engineers just said, we're going to put this really cool technology, and we're going to plug it in, and it's going to work. And it may work, but it doesn't give you the benefit of a microgrid, of an optimized energy bubble or circuit. That's a little bit about how, and by the way, a footnote here, you know, Melanie Johnson's name's on the bottom in fine print. She's one of our engineers at Searle. She and Sandia, as well as a couple of our other engineers, have really kind of gotten their heads together, and that's been a good outcome of the partnership we have with the DOE labs. And it's not just Sandia, it's NREL and PNNL and Oak Ridge and others are part of the Spiders team, and I'll get to that in a minute. But in that, we challenged every word in this kind of discussion, and a lot of that then translates into how we set requirements. And of course, then the requirements get put out on contract, and that's where I come in. My job mainly is to take this technology and promote it at a layman's level, explain it to people who are decision makers. Some of those things there, Aerospace solved in their whole, you know, launching things into space. You can't go repair those very easy if they fail. And so you had to come up with some pretty rigorous standards. And so the system of systems integration process is well understood. I won't dwell on that. So now the cybersecurity too. You know, one thing is when you start controlling things, whether it's the internet or the building automation system or a microgrid, other people may not have the same, you know, benevolent outlook, and they may want to control your system, or they may want to steal part of your system. And so that whole vulnerability of you know, as you increase your situational awareness, you're potentially increasing your adversary's situational awareness too, and that could be a very bad thing. And so some of the challenges we have is making sure as we put these smart, intelligent systems into place that we're protecting ourselves as well. And you know, there's sort of an info world and a power world, and the two are meeting sort of in a same space as we talk about microgrids. And as you can see there, there's a whole different culture as to what different terms of engagement mean. Cybersecurity, some more on cybersecurity. And by the way, we've sort of branched out at CERL and we've assigned tasks, and so everybody can't be an expert in everything, and I don't pretend to be a cyber expert, but I know we're going through a rigorous process to make sure that when we place these demonstrations that we intend to leave in place forever if they work. And by the way, the default setting is if it doesn't work, it goes back to the way it was set up, and so it's no worse off than it was before. So in case you're wondering how you do a demonstration and leave it in place, the presumption is that it'll work, it's commercially ready, and if it doesn't though, it'll be no worse than what it was when we started it. So there's some economic things here, and some of you, if you're not power or electrical engineers, might, there's a lot of opportunity here to sort of define what the metrics are that we're going after. And by the way, DoD is not going to afford all the infrastructure upgrades that it needs for all the energy security that it thinks it might need. And so we've got to look at bundling, the cyber, the security, economic opportunities into this. And of course, some folks are very green about this. So this goes into a little bit more. And here at Fort Carson, the market, no pejorative to Colorado Springs Utility, but the market here doesn't support a lot of these right now, but we're to demonstrate some of them. And as the rules change and as the grid does tighten up and demand, and right now they have more capacity than they need, but as some of these rules are rolled out, more and more of these will apply here in the Colorado area as well. And that's just kind of another way of showing some of the things that we want to consider as we're putting these in place. It's better to do it when you do it up front than to say, oh, gee, we should have put the pieces of the puzzle together to support this. Here's a challenge. I mean, every one of those symbols represents a stakeholder or someone involved in doing spiders. And so I say that, and I'm very proud of how people have come together. But it's a deliberative process. It's the forming, storming, and norming kind of process. So we're into it now. We're into phase 2. The down select for phase 2 at Fort Carson has occurred. 4 companies, big companies, lots of investment in power and energy are pursuing Fort Carson. And so the team will meet here shortly in a few weeks to select the integrator at Fort Carson. This goes a little deeper into SPIDER's objectives, but I would tell you that the extended continuity of operations, I mean, that's the energy security. So reduce the amount of fuel that you consume when you're in the islanded mode, and optimally use some of that circuit smartness to actually do some other economic things for you when it's possible. I don't think I'm going to have time to go through each one of those, but again, it just shows you sort of the graduated, we used to call it crawl, walk, run. Now we just sort of like everybody turn on the afterburners, let's keep going. So we're not crawling anymore, and we've made systemic improvements in both the technology requirements as well as the acquisition piece, which by the way is really where I come in. There's a view that many of you will be more familiar since you look from space down on things a lot, and so there you go. And that's how we're going to take that sliver of the post and all those buildings in there, and it'll be on one circuit, and we'll be able to control what gets turned on and turned off. That's phase 1 down at Joint Base Pearl Hickam, and that was small, a very small circuit. But we're treating the wastewater treatment plant as a critical load. And by the way, if it does fail, they do get a fine. Let's see here. And so I guess I'll stop on this one. Really, I think there's one other, but I was talking to Melanie, and she really wants to come next year, Melanie Johnson. She said, I'd be so, excited. She's a total into space and all that. That's one of her several hobbies when she's not doing electrical engineering. But, the risk management of placing new technology into operation, you don't get a lot of trials, and sometimes things go wrong. And I think from your vantage point, Aerospace does that really well. I think we've learned some lessons from that. I think the things need to be renewable and sustainable, and measurement needs to occur, not only when you're demonstrating it, but leave it in place, because you never know, that measurement will help you recommission and test and plug other things in. And I think that's a challenge that people haven't realized. And with that, I'll stop right there. I'll take your questions when it's my turn. Thank you.
Thank you.
I'm sorry, I didn't do a good job of segueing to David Dykes, but you're on.
Thank you, sir. Let's see if we can get things up here. Good afternoon, everyone. Thank you for allowing me to be here today. I represent the utilities. I'd love to get some questions when this is over with based on what we've heard so far. I want to talk to you a little bit about what we're doing in our service territory. My comments are going to be industry-wide for the nation. I'll try to delineate when I'm talking about that versus the Southeast and some of the challenges that we're facing, and where I think the aerospace industry, again, which you've already heard, probably could play some roles in this, with us. Just a little bit about Southern Company. I don't know how many of y'all are utility geeks, probably not very many, but that's our service territory. You can see the vital statistics there. We're a fairly major utility in the country. We're electric only. This is a footprint, and these are the major customers we have in that footprint. There are a lot of civil agencies in that mix as well, but the group that you see there are primarily the biggest and the ones we fret with the most, trying to make things work. Our future challenges center around a lot of things that, believe it or not, are coinciding with what the federal government's dealing with. Center around energy efficiency, environmental compliance, renewable integration, things that are unique to us, clean coal technology and new nuclear. Energy efficiency works on both sides. We spend a lot of time working with our customers trying to get them to conserve less. Although I make a profit on every kilowatt hour I sell, I only want to sell you what you absolutely minimally need. Because when I do that, I lower my emissions generation. It helps me out as well. And it allows me to bring in new customers into the service territory, thus lifting the whole economy of the service territory that we serve. We're transitioning in fuel right now. We're moving away from coal. We're moving to gas. Two things are driving that. One is the environmental issues. The other one is the simple price. If you have been tracking gas prices right now, they're at a fairly all-time low right now. And what we're doing is we're taking what we used to run as intermediate gas plants, and we're base loading those. And what we used to run as base loaded coal plants are moving up to stack, and now are intermediates. So we're burning a lot more gas. Renewable integration is one of those areas that we're really puzzling with. It's not a real big deal for us right now. When I say intermittent, I'm talking about solar and wind. We don't have a great deal of solar in the Southeast, and there's probably less likelihood of wind. We're doing some meteorological studies along the coastlines of Georgia and in the Gulf, trying to see if we can get some data and see if we can substantiate the process of maybe putting some windmills in that area, but we'll see. And the issue with our intermittent sources from a utility standpoint is we live and die by reliability. And again, right now, the renewable resources that are intermittent in our service territory, and probably throughout the country at this point in time, are relatively small. And there's enough inertia in the existing utility systems from traditionally produced electricity, traditional generation, to be that shock absorber. So that when a cloud comes over in a large area and dims out the solar array, the system can pick up and handle that load. But when you start to get to the level of 40, 50% of this, we're going to have some challenges. And again, the space industry has been working off the grid for a very long time. You've dealt with these problems, probably not on the megawatt scale or gigawatt scale, but obviously you have some knowledge, and that could probably be a good benefit to us. In the Southeast, we're blessed with trees. We have more trees, and pardon the pun, you can shake a stick at. Most of it is tree thinnings and waste from logging operations. We don't cut round wood. But we're trying to establish a market for that and to come up with some biomass-fired renewables. We actually have a 100-megawatt wood-fired renewable plant currently under construction outside of our service territory in Natchitoches, Texas, I believe. It'll be, when it becomes operational, it'll be the largest biomass plant we're operating at the time. Talk about clean coal just a minute, and that's our term. Coal is an abundant fuel source in our country. It needs to be part of the mix. It needs to be part of the arrows in the quiver, as our CEO says. We have developed in concert with DOE through a partnership agreement relatively new technologies. We have patented those, and we are now disseminating those out to our industry, both within the U.S. and throughout the world. We're currently building a plant in Kemper County, Mississippi. It'll utilize this technology. It's basically a gasification technology. Through that gasification process, we're able to extract about 60% of the CO2, put it in a pipeline, send it to the oil fields, and they can use it to extract more oil from existing fields. And then on the new nuclear side, I'm proud to say our company has received the first combined operating construction license for 2 new nuclear units being built at our Vogtle site, which is south and east of Augusta, Georgia. Those will be 2 1,100 megawatt units. We own half of that plant. We don't own the entirety of it. We have several partners in that one. But those plants will become operational in 2016 and 2017. There we go. So, mutual goals. We have a significant number of mutual goals with the federal government, again, centering around energy efficiency, renewable greenhouse gas reduction, and energy security. As I said, we're transitioning because of fuel and environmental issues. Coal's going away. Across the nation, we're going to see substantial numbers of coal plants closed. In our service territory, we already have scheduled and certified through our commission closing of about 4 units. Doesn't sound like much, but these units average about 800 megawatts apiece. It's a pretty big chunk. And with that comes a lot of political outfall because that means people are losing their jobs, et cetera. So it becomes a very contentious issue. Renewable energy, again, we don't have a renewable portfolio. Very few service territories in the Southeast have it, except for North Carolina. You find the renewable portfolio standards in areas in the Northeast and out in the West. You also find substantially higher energy costs in those 2 locales as compared to the Southeast. And there, renewables make sense. They can sometimes achieve parity with grid. It's going to be very difficult to do that in the Southeast. Our average price is probably around 6 cents for large customers. Greenhouse gas reductions, again, the government has a goal on that. We have permitting issues that we try to work within and stay and reduce as much as we can. And then touch on energy security. Again, we're going to be retiring plant. We're going to have to replace some of that plant with new stuff. It'd be a great idea to maybe work together with the federal sites and maybe co-locate some facilities on those. And I'm going to show you a real live example where that's been done. Biggest partnering opportunity I believe we have deals in the energy security and the renewable energy side. Again, as I said, we're transitioning from coal. We're going to have to replace some generation. Why not do it on a federal site? We've discovered that most of the federal sites that we serve are open to this notion. We haven't gotten to a completed plan except for the one I'm going to show you, but it is a workable solution, and it's a way of jointly leveraging each other's resources. And that example I'm going to show you is Robins Air Force Base. As I tried to describe the current set of goals that both exist on the federal side and exist on the utility side, I liken it to somewhat of a perfect storm. Well, we had a similar perfect storm back in the 1980s, at least in our service territory. And we were short on peaking load. That's that generator we fire off when all the air conditioners come on and drive off that nasty humidity that hangs around the Southeast. We went with, we contacted actually the Air Force came to us and said, we know you are going to be adding capacity. Why not consider doing one on our site? And so we got together and worked with it. It took about 3 years to put this in place, but ultimately we built a CT site, combustion turbine site. Nothing more than a jet engine with a generator tied onto it. If we were doing this today, it would be a combined cycle plant. But at Robins we have, and this is a fleet dispatchable unit. It's owned and operated by Georgia Power Company. 280 megawatt CTs. You can read the specifics on it. Back in 1990, it was real cheap to put these things in. And we funded the entirety of this project because the plant was certified by our commission. The base's responsibility to us is to provide us with black start capability. And we run an annual test. That test was run 3 weeks ago. Everything passed in flying colors. We've actually operated Robins only one time in a completely islanded state. When the plant was built, we have a transmission line that enters from the south side and exits the base about mid-base. Switches were installed there, remote controlled, and we can actually isolate the base from the rest of the system, fire the generators up. re-energize that section of transmission within the fence line, re-energizing both substations. And as far as Robins Air Force Base is concerned, nothing's changed. They continue to operate full bore just like they always have. What the benefits you can see down there is, again, it gives them a secure site on their property. And I want to point out, this is not a power purchase agreement. A lot of people get confused. They are not buying the output of the plant. They're buying their energy, whether it's coming from the plant or coming from the grid, in the same fashion. That's it. The unit in the foreground is Unit 1. The unit behind it is Unit 2. You can see the substation, transmission lines going out. Again, this has been operational since 1995. Here's an aerial view. The tank in the berm is 1.3 million gallons of fuel oil. It's enough to run both units wide open 7 days. But keep in mind, that's 160 megawatts of production for an installation that's nowhere near that size. So if we ever get into a condition, we probably got about 2 weeks supply there. The units can run on JP8. We have to get them certified through our Environmental Protection Division of the state of Georgia, but that's all that would take. And with that, I think my next slide is questions, and look forward to it. Thank you. With now, okay. And I'd like to turn it over to my esteemed colleague, Paul Bollinger.
Thank you, Dave. Appreciate it very much. I'll sit here. I'm a little farther away from Dr. Siga. He might pull on my jacket and tell me to sit down, but that's okay. I was at the opening reception, actually the reception for the speakers before the opening reception, and I had Mark Stevenson, the honored guest speaker for the final banquet, walk up to me and he said, let me guess, you're not a space guy. And I was looking at myself, he said, what, is it show that much? And he says, no, but you're standing out there. And I said, well, I'm looking to blend in. So what I want to do here today is take some of the comments of Gene and Harold and Dave and the fine opening that Dr. Siga did and present it to you in a way that ties more closely in the issues of energy and space and what we are trying to do and the reason Boeing is even involved in this area, given our over 50-year heritage in space and what we are trying to do with smart, secure microgrids on Earth. So I would stand up there, but all the footnotes that Dr. Siga made me put on his slides when I worked for him has caused my vision to change, and these are a lot easier to read sitting down here. So what we've got is the space station, which you're all very familiar with and you've seen lots and lots of pictures of, covering over a football field in size. And what its attributes are that are very close to those associated with smart, secure microgrids are that it's a self-contained, secure power system. It's scalable. It's 100% reliability. And it fully powers the environment control and life support system. It's a system that generates about 110 kilowatts of power. And again, as Dave said, we're talking about megawatts here on Earth, and we're talking about 110 here. But when I look back through some of Boeing's satellites, we were producing satellites back in the 60s that were using anywhere from 1 to 4 kilowatts of power. And that exponential growth in the power demand is going to provide a great opportunity for us in the future to create greater similarities and draw on the technology that is coming out of the space station and the satellites. And there's a number of particular areas. The energy situational awareness on the space station is dynamic. It has a variety of experiments that are conducted on the space station, and they generally are consuming about 30 kilowatts of energy, and as well as supporting the life support system and the vehicles that come and dock and depart, and the change in the number of visitors on board, as well as the solar arrays being shadowed as it goes in orbit. The intelligent load management system, the system prioritizes loads. It distributes energy accordingly to that priority, and it has circuit isolation devices to remove loads from the system. It's energy storage, which will ultimately be the key to the Rosetta Stone for any of the smart microgrids on Earth, is something that is very advanced with the space station. It uses the nickel hydrogen batteries, and those batteries are due to be switched out, as noted here, with lithium-ion batteries in 2017. But there's going to be a difference there. You have the power that is generated by the nickel hydrogen batteries is only a third of the lithium-ion. But the strong suit of the nickel hydrogen batteries is that they can handle 20,000 discharge cycles, 20,000, with 85% efficiency. And that's a huge, huge number. And I think one thing that I found out that was really fascinating, when you take a look at the Hubble telescope, when they went up and replaced the nickel hydrogen batteries after 19 years of operation. And that still holds the record for number of cycles, which, again, this is something we can only hope for with our Earth-based microgrid systems. So, applying the proven aerospace power technology to our energy security on Earth, our planned smart grids and microgrids have many of the same characteristics. Big focus on Earth, obviously, is the distributed energy resources, which could be wind, solar, biomass, you name it. And I think Dave did an excellent job of explaining from the utilities perspective of the variability that the renewable energy can cause to the grid and the concern that has for the utilities, and which is one of the important reasons that smart, secure microgrids need to be a component of this renewable energy, or else you're sticking a very volatile piece of power production on the grid that can create similar situations as a branch in Cleveland. And that's something we don't certainly want to repeat history on. Keep moving here. So finally getting to some pictures and off the words, and what does a microgrid look like? Everybody has their own interpretation of what a microgrid looks like. This is ours, and what it's showing you is a base, and the various buildings on the base, the various different storage and renewable energy components, the battery storage, and how it is all linked with a microgrid optimization and control system. Again, like the space station smart control system, also has the capability of being able to utilize electric vehicles, which is still a component that is being viewed and considered quite closely as a potential energy resource with their batteries. But then there are a lot of questions about its use of those batteries, and then when are you using the vehicles and how that interplay works out. And thanks to Harold and Spiders, that is one of the test elements that will be determined how that works and if it works in the future. So that should be very interesting. What you're getting to, though, with a smart, secure microgrid is the ability, if the grid should fail, to continue operations. And like Warner Robins' example is that's continuing operations with conventional power, so gas power. What we're looking at here is using renewable, and it's not strictly renewable. It could be a situation where Robins Air Force Base also is utilizing that same approach on other bases. So if we went to the utilities, and the utilities, those that need additional peaking power, could be encouraged to locate that power on military installations and bases, that would be a very nice symbiotic relationship where you have the renewable power backed up by the conventional power on that base, and it all interconnected in a smart microgrid, so that that variability does not enter the grid and cause conflict with the utility's overall service to its customers. And I apologize for all the information on this chart, but it really takes the pictorial that you just saw and breaks it down well into each of its key component areas. And Boeing is developing an integrated solution that we call our Smart Secure Microgrid, which will be the backbone of energy security for the base. All legacy systems will be merged into a new system in a way that brings cybersecurity as close as possible to every existing endpoint with little or no changes to those systems. And a sophisticated demand response will allow the smart meters to be utilized to communicate either not just what the power usage is on that specific building, but how to control that power to either increase it or decrease it depending on the situation that you're confronted with your energy system. So again, this is looking to lay this down in a seamless grid that would then be able to potentially, with the close coordination of the utilities, be able to potentially push power off a base or an installation to the police, the fire, a hospital, or other critical infrastructure off of a smart grid. And what does the future hold? This little wheel chart shows you some of the challenges that we face. I think one of the big things that we face right now, we have demonstration projects for smart microgrids going on around the country, and we're looking to elevate that to full-scale projects. The demonstrations will be about a year and a half, so we want to take the lessons learned from spiders and other programs and then wrap that into a smart, secure system. The challenge we have is, as you may have seen and heard here, as the budget impact on NASA is very, very critical. The initiatives that the military is attempting to go after have no money behind them. Most of these programs are third-party financed. So the savings that are generated by a smart microgrid system are then used to pay back that third-party investor in the system. So there is a very different approach to energy, renewable energy, on military installations. And we get the question asked, what's the return on investment? Tell us, what is it? And I thought it was very interesting. In today's Washington Post, it was said that, let's see, I had my notes here. It was, no, I think, what was said here? I've got this. James Cartwright, former vice chairman of the Joint Chiefs of Staff, said at a recent CSIS event that even a limited cyber attack on the nation's power grid or financial system could spark tremendous public fear and probably a phone call or two to the Pentagon. And what is the ROI? According to Scott Borg, chief economist of the U.S. Cyber Consequences Unit, a research group, has assessed the annual loss of intellectual property and investment opportunities across all industries at $6 to $20 billion. $6 to $20 billion. And so they expect this next cyber. In fact, they mentioned one company that over a weekend lost $1 billion of R&D over one weekend. So, FBI Director Robert Mueller has said that cyber attacks are likely to eclipse terrorism as the top menace to the country, and energy is likely to be one of those targets. So that's why a smart, secure microgrid system is something that we are very anxious to have. It's something that early on in the Space Symposium, the keynote speakers on Monday said the benefits of space exploration are taken for granted. Well, so is energy security. And without it, the warfighter and space program will be very challenged. But I believe working together to capitalize on the solutions created by space exploration, energy security on Earth can become a reality. Thank you very much.
Well, thank you to the panel. I think it was a pretty good story, and the interest is high. I have 2 pages of questions here, or I think 15-some questions that have been asked by the folks, which needs to acknowledge the Space Foundation for actually adding a session on energy. I believe the first one ever to the National Space Symposium. First question, and I'll take this, and then the rest of them are going to be with the panels. Can you talk about some of the challenges of putting together the Colorado test bed, especially the different county or municipal jurisdictions and their friction points and issues? So we named this initiative the Rocky Mountain Secure Smart Grid Initiative, and it had 5 communities involved: Fort Collins and Colorado Springs, they are served by municipal utilities. Boulder and Aurora, served by investor-owned utility, XL, and Windsor, a rural electric association co-op. And in one of the munis, Colorado Springs, had military installation. One of the communities, investor-owned utility, Aurora, had Buckley Air Force Base. So there's kind of balance there. There were 40-some industries that actually joined along with this. And so the interest in industry in providing innovative solutions was very, very high. Now, there's slightly different rules and regulations, and that's one of the challenges of us getting a fully integrated systems approach for energy systems that are truly efficient, resilient, secure going forward. So, yeah, there were challenges, but at the same time, I think that's very necessary to demonstrate and get data at sufficient scale to help inform on national standards. Next question. I'll send this to Gene. What are we doing to protect our critical infrastructure?
Well, we've come a long, long way over the last 10 years in particular, but one of the challenges really was that all of the interest groups were really focused on creating better security around those critical infrastructure nodes. And I'll just use nuclear power plants as an example, but there are many other nodes. The owners of the plants clearly were focused on providing sort of site security, and they generally had done a pretty good job. The difficulty was that as soon as you began to extend outside the fence line, it became much more murky. For example, what was local police's response capabilities for that particular site? Were they even trained in acting in a nuclear environment? Where did the Department of Energy play? Mostly regulatory. There was a growth in response teams that were capable. And in fact, initially, the only response team capable of arriving at a nuclear event came out of U.S. Special Operations Command. They had a very different mission, but they had the tool sets. About 5 years ago, the FBI was given the principal role responding to nuclear events for the investigative piece, but they didn't have the training to operate in that kind of an environment. So there was a cascade of challenges to overcome. Now, I'm happy to say that we have, over the last 4 years, exercised against a couple different critical infrastructure scenarios. We've got complete buy-in across the board. We've created the swim lanes that says DHS has the principal responsibility, but DOD has technical expertise. And then the utilities, the contractor, individual investors, local law enforcement, first responders all have roles as well. So we've come a long way in that regard, but there's still a good way to go.
Okay, just as an administrative question, I think we have till 3:30. Is that right? Another about 5.5 minutes. Is that correct? I'll take that as a
So
yes.
reset the 5-minute clock.
Okay, yeah, I think that's right.
Of the chair.
Okay, Harold, I'll try to combine two of the questions here. One is, can the existing power grid be turned into a secure grid, or would it require an entirely new one? And others can clearly contribute to that. And can the island/microgrid approach be used to minimize the impacts of storm damage? So there's kind of two related questions there.
Yeah, the short answer is yes to both. I mean, you don't have to start over. It is a challenge to deploy technologies onto legacy systems, but it's a lot like the rollout of the internet. You know, we're putting sensors and nodes and control strategies in place. And as you do normal upgrades, then you can upgrade the interconnection pieces as well. So far, I think it's working the way it should. And long term, I think these islanded or these microgrid boundaries can be shifted and blended as more and more people adopt what I hope will be something that DoD leads the charge on. And that's kind of like your slide, Dr. Sega, that showed the different domains and how they step up into certain blocks. And I hope at the end of Spiders we'll have block A, if you will, of what DoD bases should look like.
Okay, thank you. David, you may want to follow up on that issue in terms of going to a secure grid and the issue of how it could help in impacting storm damage, and I'll follow it up with another one.
My answer to this is going to be strictly parochial within our company. We're spending billions, and that's with a B, on that very issue. We have implemented a complete rollout of smart meters to all customers now. Those meters are talking to smart devices in a distribution system. Subsequently, those devices are talking to the transmission system and follow on up the chain. Secondly, we have a generation control management system that basically is centrally controlled through two secure distribution centers. We have additionally about 3 others hardened and strategically located in the service area. I don't know where they are. They won't tell us. Where systems can be transferred basically with the push of a button. Our generation control system is operated outside of any internet connections. It is operated under our own internal control and comm systems. You know, we didn't much like Southern Bell when they were the predominant telecom company in our region. We built our own communication system because we didn't think it was reliable enough. This is a big concern for the industry. All the utilities are working very diligently on this. All utilities are participating in a number of the DoD and Pentagon tabletop studies on how you respond. We talk about storms. We can put the whole system underground if you wish to pay for it. I will tell you that it's probably not very practical and it is not very cost effective. You know, when Katrina came aboard, Katrina hit our Mississippi Power affiliate. It wiped out the entirety of the above ground transmission and distribution system and took out some of the substations as well. But I want to tell you that 11 days later, anybody who could take power had power. And that doesn't mean that it was 11 days of waiting and then you had power. There's a hierarchical control and reestablishment of service within all utilities. It doesn't just happen by happenstance. It is planned and it is rehearsed. And we do it once a year. We get generation on first, transmission second, substations energized, distribution, and ultimately down to your individual homes. Within 24 hours after Katrina hit, we had most of the transmission system critical loads up and running. And for our area, those critical loads included gas pipelines, both natural gas as well as petroleum pipelines, because most of that fuel flows from the Gulf Coast through 3 of our service territories up into the Northeast. And if those pumping stations aren't running, the Northeast is being starved for fuel. So I'll give you some things. We have hardened facilities, especially on the coastline in our service territory, and it is a big concern. The industry overall over the next probably 5 to 6 years will spend in the neighborhood of about $15 billion, again with the B, across for modernization, intelligence improvements, and then overall hardening.
And in answering those questions, we got another 5 off a text thing, but so we're sliding further behind, actually. Paul, what are the barriers facing space and aerospace companies in commercializing their energy technologies? Are these companies in a position to enter such non-core markets? How can policy encourage the transfer of these technologies into the power sector?
Well, that's one of the concerns that Deputy Undersecretary of OSD, Dr. Dorothy Robine, had mentioned. She wants the new technology brought into the bases, and that is more expensive. Whereas if you're doing the energy savings performance contracts, which you're getting paid back for through the savings, the third party generally does not want to put in a more expensive unit where it's going to be longer for them to get a payback, or the payback margins are going to be thinner. So that's the first challenge. If you don't solve the funding mechanism, which right now, if you want something the third party has to bring in and pay for it, the military is paying for very, very little, if anything. What has to be done? There are challenges, because we will be competing with the new energy resources, the new battery technology, with the utilities that are using conventional power, that in some cases may even have that power subsidized to the military base. So when you come in with your project to that base, you're competing against subsidized power, and we know that renewable energy is a little more expensive, unless you're trying to compete for it in Hawaii or the Northeast, potentially California, where it's more expensive. So we need to level the playing field. And what does that mean? It means that that means the military would end up paying more for conventional power. Are they willing to do that? They're probably not during budget cuts. But it doesn't answer the energy security issues unless you come up with a Warner Robins or a Tinker Air Force Base solution where they're co-locating that generation on the base. So in summary, we have to get the cost down for that technology so it's competitive with legacy conventional power. And there's got to be other transitions because the transmission system in the United States expects that it needs about $1.4 trillion worth of investment in the next 20 years. Where's that money coming from?
Okay, as we've run out of our final reset of the clock here, I have to kind of bring this to a close. I acknowledge that the numbers of questions that have been sent in that we didn't get to covered such things as new battery technology, solar cell design, unity of effort across solar services and modernizing and securing energy, national energy policy, and cost and so forth. Excellent, excellent questions, and I think motivation for perhaps a follow-on session in this very area at some future time. With that, I'd like to thank the folks on the panel for participating and those that joined us today. Thanks.